Hello. So today we'll be learning about powers, exponents, squares, and logarithms. So let's start with what an exponent is. So how is an exponent written? It is written in this form. And that's not how I'm supposed to do it. Sorry. But this is how you write exponent. So what does this mean? I can just show you this equation. Like, let's say 2 to the power 3 equals what? Equals z. Z equals what? You would have no idea. So, what is it? Well, you have x into x into x, so on, y times. Okay, so that means if I add 2 to the power 3, this would equal 2 into 2 into 2 3 times. So I multiplied 2 into itself 3 times. 2 is the base, which is the thing that multiplies itself, and 3 is how many times it multiplies itself. So this would equal 8. Do some simple calculation. Now, let's see how this complexification can become. We're dealing with positive exponents. An exponent is this part of it, or the y part. And, wait, is there a different way to... So, that's basically how it works. But what if we use 0 as y? 0 equals y. This could result in 2 to the power 0. Now this is a bit complex and a bit baffling. You would think it just equals 0. That's wrong. So let me explain to you what is the correct answer. So let's start working our way down. So we start with 2 to the power 5, which equals 32. No, 23. Then 2 to the power 4, which equals 16. Then you have 2 to the power 3, which equals 8. Then you have 2 to the power 2, which equals 4. Then you have 2 to the power 1, which equals 2. And then you have 2 to the power 0. Now, if you see a pattern here, this is just this is just this divided by 2. Right, and it keeps going like that. So, technically, 2 to the power 0 should just equal 1. And that is the correct answer. So what if we keep going? Like 2 to the power negative 1. Well, this equals 1 over 2. Divide that by 2, you get 2 to the power negative 2 equals 1 over 4. And you keep going. But if you look at it, you can say that, hey, look, 2 to the power negative 1 is just 1 over 2 to the power 1. So you can basically see 2 to the power. You can look at this and say y to the power negative x equals 1 over what is it? 1 over y to the power x. Now this will probably also work even if you put x as a negative value. So it becomes a negative negative, which is a positive. So let's see what would happen to that. Well, you'd have 1 over y to the power of x. And let's say y equals 2 and x equals negative 2. So you'd have 1 over negative 4, which equals 1. Wait. What did I do wrong? See, even I get stuff wrong. So, let's see what happens if x is negative. Which means it should be y to the power negative of negative x. Okay, and x is positive in this scenario. So this would equal, technically it should equal 1 over y to the power negative x, which will equal negative 1 over y to the power yx. Y to the power x. No, x is still the positive number, correct? And I don't know what it is wrong. Maybe this is just a weird way of doing it and doesn't apply to it. But yeah, that's basically how it works. Now, what if you looked at this and you said, hey, what if I did 4 to the power 1/2? Now we go into a new chapter, because this goes into the new chapter. A square root is written in the form of y. Wait, I need to do something. Square root symbol. Square root symbol. Copy paste. So I can go here and I can do Command V. Square root of z. Okay, it's written in this form. Y is the exponent, z is the answer, and you have this. Now, the answer you want is x, the base of our equation. Now, let's figure out something new in the exponent chapter. If we do 2 to the power 1 into 2 to the power 1, this equals 2 into 2, which equals 4, which equals 2 to the power 2. But this may not be good enough explanation for you. So let's do 2 to the power 2 into 2 to the power 3. Well, this would equal 2 into 2 into 2 into 2 into 2, which equals 2 to the power 5. Now, 5 equals 2 plus 3. This is obvious. You wouldn't look at this, but 2 and 3 are this and this. The exponent is 5, and it's the same as adding the two exponents of the powers you're multiplying together. So now you figured out another equation. Our equation is 2 to the power x is equal to into 2 to the power y equals, no, that's not good. Z to the power x into z to the power y equals z to the power x plus y. Okay, and it only works if z is the same base in the both of the powers. Okay? So now, let's do another thing. So technically, 2 to the power 1/2, 4 to the power 1/2 into 4 to the power 1/2 equals 4 to the power 1, which equals 4. Now, what into what equals 4? Well, this also can represent it by 4 to the power 1/2 in parentheses to the power of 2. Now, you're trying to find what 4 to the power 1/2 is, which is the base. Now, what we're trying to find in a square root is the base. So, in this scenario, we know our exponent, 2, so that's there. Then our answer should be 4. And that means that the exponent of this is 2, right? Because 2 to the power what equals 4, you know it's 2. So let's see what 2 to the power 1/2 is. So you know the exponent is 2. Since you multiply each side, you do that into 2, and your answer should be 2. So the exponent is 2. Your answer is 2. And what is this equal to? Well, now and look at this. Just no exponent is usually 2, okay? This is how it usually is. This and this are the same thing. The exact same thing. Okay? So we can now shorten this. Square root 2 is what? Now this is an extremely hard question to answer. But square root 2 and 2 to the power 1/2. It feels like when you do 2 to the power 1/2, it gets you square root of the number. And that's extremely correct. So, we have another equation. 2 to the power 1/2 equals 2. Okay? That's our equation. That works. Now, let's make an even better one. Even better to understand. X to the power y over c equals z. For and soda will always be. Wait, so let's see. X to the power y over c. C. So you multiply it z times. You do the power of z. So that gets your exponent. Then your answer should always be x, no matter what. And this equals, and the y factor is, wait, let's think about this. You divide it by y. Divide by y. Think. Wait, so let's make an equation of this. So if I have 2 to the power 2 over 3, let's say this, then RZ equals 3. So it's 3 3 of, or x should be 2 over divided by 2. I don't know. To make this a little easier for us, since this is irrational, so it'll be harder to express. So let's make it 4 to the power, let's make it 16 to the power 3 over 4. Okay, so now using our equation, z should be equal to, so the z part is 4, and then our x is 16, and our y is equal to, our y is equal to 3. So let's calculate this. 4 square root 16 is square root 16 is 16 divided by 3 is, so this just equals 16 divided by 3. That does not make sense. No, I don't know. But basically, this is an easier and better equation. This equals x. This equals y. X. That's it. That's our equation. So now we have this. So let's see. Is square root 2 like pi? Let me just make pi. Pi, copy. Copy, paste. I need to go in. Okay, there we have it. That's copied. So, is it like pi? Is square root 2 like pi? Well, let's see here. Is it? Now, what is a rational number? When one is odd, when both have no similar factors. Because if they do, then you can simplify it. So basically, an odd and an even number might share factors. So like 6 over 9, it's odd and even. So no, you can simplify that. 2 over 3. It's the most simplified version. And then there's a simplified version. That's a rational expression. So square root 2 would be equal to 2 to the power 1 half. Okay, I don't know this, but square roots, I showed you what a square root is. I'm not really that good at square roots, but logarithms is pretty simple. Once I'm done with this video will end. That will be it. So I think in my next video I'll explain how to do the square root, prove that square root 2 is irrational, not rational, and logarithms. Logarithms is set in this way. So we've looked for x, z, and what's left? Y. So how do we write log? Well, we have our base underneath. We have our answer z on the right side. And then we have y. This is how it's written. Now, let's see. What do we do here? We can use this to find some things. Logarithm is even using earthquakes for scale. So 1 is 10 to the power 1. Or 10 to the power 0. So 0 is 1. 1 is 10. 2 is 100. 3 is 1,000. And it keeps going exponentially. So now, also, if they don't show x is unknown, just say x is 10. Okay? That's the normal set. So that's basically it, and hope you have a good day. Tell me if I'm wrong in the comments, and yeah, that's it for this video.